made, but not yet sufficient, giving us a reason to do more research on design and analysis of experiments. BIBD being a high-end form of design, it has several applications in so many areas. Now, several methods for construction of BIBDs have been suggested, including the trade-off method, the difference method, variety cutting, construction from finite permutation groups, among others. An algorithm for constructing symmetric, balanced, incomplete block designs, that is SBIBD, as indicated in that slide, from affine resolvable design was developed by a Nigerian known as Oswalale and Tekunrin. Now, when you say an affine resolvable design, those are designs that you can partition the blocks into small fractions of the replication. This followed after a close analysis of the 3 R's that are used in design analysis of experiment, or the 3 principles, basically known as blocking, randomization, and replication. The fact that we were able to show that if you take R multiplied by V, you will get a value which is equivalent to B multiplied by K, where R is the number of replicates used in that design, V is the number of treatments, and B is the number of blocks. Then K is the number of times a given treatment appear within the design. And also the fact that taking the number of replicates into the number of times each treatment appeared, if you take away 1, which we can say the degree of freedom for K, should give us a value lambda into V minus 1, where lambda refers to a parameter in which the number of pairs, the number of pair of treatments within that design exists. The main motivation for this particular study was the fact that no algorithm for a method known as sum construction method of balanced incomplete block designs has ever existed. And this necessitated a study on efficiency of sum constructed AUSBIBD implies automorphic, symmetric, balanced, incomplete block designs. Next. A few concepts that will make one to understand what we are talking about here. One of them is design. When I say design, I'm referring to an ordered pair XA, such that X is a set of points and A is a block on those points. So the definition of a design is given, or you can say a design is simply a set of points and a family of blocks forming that of the sets. The second definition, just a little before, is about isomorphism. You can't talk about automorphism without mentioning isomorphism. And we are referring to isomorphism as a one-to-one mapping between 2 designs of the same type that can be reversed by an inverse mapping. If you have a design that maps onto the other and you can get the initial design by a reverse mapping, then we talk of isomorphism. The next. Automorphism now can be treated as an isomorphism or a mapping of an isomorphism onto itself. You are talking of having a bijection or a symmetry preserving permutation without changing the contents. In the concept of block balanced incomplete block design, we can treat automorphism as a one-to-one mapping of the blocks of a given design onto themselves. And that is what forms the title of this particular study, the automorphic, symmetric, balanced, incomplete block design. We go ahead to say that a design is considered symmetric if the value of blocks is equivalent to treatment, and the value of replication is equivalent to the number of treatments that are the number of times the treatment appears within the blocks, that is K. And then when we talk of sum construction, then we are referring to a systematic addition of a fixed value to the treatments of a given design so that you obtain new blocks that will form other designs. The main objective was to determine the efficiency of some constructed automorphic symmetric balanced incomplete block design, of which we could not achieve without performing the sum construction of such designs. Then the significance of the study, just as indicated in that slide, we talk of currently the idea is being used by farmers around Muhuru Bay in Migori County to do watermelon, doing pairs of given variety together so that they are seeing how they compete for the nutrients. Next. The model that was employed in this particular study is a simple model of a BIBD having the estimate of an observation Yijk equivalent to the grand mean mu plus the jth treatment, the ith treatment effect, that is tau ij, and then the jth block effect plus an error term E epsilon ijk. Next. It is worth mentioning that that model was chosen because it is believed to be giving a series of automorphic SBIBD, symmetric balanced incomplete block designs. One of the assumptions that we did consider is that the error term is constant so that the F-test that is used to give the results could hold. The sum construction method involves taking a single value and adding to the treatments of the blocks of a given design, which we called parent design. Now, the theorem that necessitated this is the fact that if you are given a design whose parameters are V, K, and lambda 1, and another design whose parameters are V, K, and lambda 2, then we can use the summation of the values of lambdas, which is the number of the pair of treatments appearing in a given block, to come up with V, K, lambda 1 plus lambda 2 as a method known to construct new designs from existing. Of course, we are saying the two are existing, so you can get a new one from these ones. Okay, next. An algorithm was developed in a Python to aid the process, because doing it manually in the current world is archaic and of old style. So we did codes in a Python and came up with just at a click of a button, you are able to perform the sum construction in a Python program. The steps are described. Maybe in the interest of time, I may not mention, but I can just say the codes were developed in a Python program. Next. For the data set and the efficiency of such designs, we obtained data from Kemfrey, Kisumu, Maseno branch, and the data was arranged in 3 different sets. Set 1, considered to be the parent design, design 1, where the value of lambda was treated as 1. That is, the number of pairs of trees that were in that field were just appearing ones. Then set 2, lambda was set to be 2, and set 3, lambda was set to be 3, so that the third set was now the sum constructed design. Then we subjected this to an efficiency test by that equation, and also moved it further to get the relative efficiency based on the analysis of variance tables that were generated and the degrees of freedom of those particular 3 designs, design 1, design 2, and design 3. The results of the sum construction case, if we have this as our parent design, are where the rows are the blocks. There are 7 in number if you can count. The columns are 3, that is K. Then V is the treatments, which we are saying there are 7, so they will move from 1, 2, 3, 4, 5, 6, up to 7. They are arranged to take care of those conditions that I did mention. BK is equals to RV, and lambda into V minus 1 is equals to R into K minus 1. If we have that as the parent design, then you decide to choose one of the blocks at random. If I pick 1, 2, 3, which is the first block, and then set my lambda 2 to be a value which is 2, and then I perform some construction by adding 2 to 1 to get 3, to 2 to get 4, and 3 to get 5. In the next one, I'll be, I got 3. When I add again 2, I will be getting 5 in that order. In the next slide, we will have the results, please. Yeah, so you can see we added 2. This is a case when lambda 2, which was added, is 2. From 1 to 3, we are able to get 3, 4, 5. Then you can generate new designs from that by continuing to add 2. 2 plus 3 gives you 5. 4 plus 2 is 6. 5 plus 2 is 7. If I add 2 plus 5, I will get 7. 6 plus 2 is 8. But I don't indicate it as 8 because we only had our treatments ending between 1 and 7. So 8, we use what we call the modulo algorithm, when we just think of the remainder and only. So if it is 8, instead we put it 1. Divide 8 by 7, you will have remainder 1, something. Then 7 plus 2, you get 9. Instead of 9, because our treatments are ending at 7, we will have a treatment what? 2, using the modulo algorithm form. 7 designs could be obtained from that process. But you see, arriving at all of them manually is very difficult and tedious. So we opted to do that using an algorithm, which maybe Dr. Gesa will spare me just 1 minute to show. The next slide, please. So again, we did when we considered the number to be added for some construction as 3. What that implies in the real life is that if you go to the sector of agriculture and you're having your trees that you want to see how they are competing, then you put the 3 species together in one plot, again, other 3 species together, and see how they're competing. Good. Now, the efficiency of the designs that were used, design 1, design 2, and other designs were computed using that formula that I indicated. I need to maybe uphold the quotation that that formula was developed by somebody called Parvati. So we only used it to give the values. It is worth noting here that the efficiency of these designs is directly proportional to the replication treatment ratio. If you increase it, you increase the replication treatment ratio, the efficiency will also increase. Next. And then the relative efficiency, as I said, is also a green area in statistics. In the past, only for randomized complete block designs have the efficiency being compared, even in literature. But for BIBD, I think this is the first case we are having here. We based this on the degree of freedom of the outcomes of the analysis of variance table that we generated from the data set that we used. And what we got here was comparing how the new design performs with respect to the parent design, where they were generated from. So you check the formula that we used is there. The next slide. For design 1, when compared to a sum constructed design, it was giving a value of 1.216. And the interpretation is that that means the sum constructed design is able to give more information in terms of the blocks and the treatments of about 21.6% better than the parent 1 design, which had a lower replication level, lambda being 1. The next. It is worth discussing that some constructed designs, if you look at the analysis of variance, more of the values, more of, you call them the sources of variation, were significant. And that is the pride of any statistical test, having what you are testing being significant. Meaning, if you use a sum constructed design, then you are able to get a better output or a greater value of efficiency. design 3 provides more information than design 1 and 2. If a design provides more information per block, it implies it is efficient. Okay? So we can say a sum-constructed, automorphic, symmetric, balanced, incomplete block design is more efficient compared to the parent design that were used to develop it. Now, in conclusion, we conclude that it is possible to construct automorphic, symmetric, balanced, incomplete block design using the sum construction method. And finally, the sum constructed designs are better in terms of revealing information per block for those designs. Okay, I don't need to talk about that. Now at this stage, before you clap, probably I would just take 1 minute to show that once you have the codes ready, you can do I want this. So here I have the codes that we did develop in Python language. So there we are. Once I have saved it, you can just recall and then key in the value to be added, and there you have the designs at a click of a button. So the codes are saved in this desktop as serial in a Python file .py. I'm just recalling it. So at that point, maybe if I click on enter, it will prompt you to key in. Please key in the number of designs that you want to generate. That will be maybe pegged on the value of the V. If V was 7, then you can just say develop or generate 8, 9, or 10. Or even 100 if you want, but then they'll be repeating themselves for that automorphic nature, one-to-one mapping, if you rearrange those treatments. So probably I say 8, and then I enter. Then now it's asking, please key in the number to be added to the design. Which is this number that is going to aid the sum construction? You can choose 1, 2, 3, but not a number greater than the total value of the treatments. So I can pick any number for our case. That design that had treatments up to 7, I can pick any number between 1 and what? And 7. So if I choose to pick on 2 to be added, then I enter. At a click of a button, those designs are generated just as a click of a button. And there we are. Thank you, Dr. Gesa.
Thank you very much, Dr. for that wonderful presentation. But it was so abstract for some of us. And you kind of lost some of us. But I want to ask a question. When you said you are treating, like for instance, you use 2, and then when your number goes to 8, it changes to 1. How do you differentiate 1 and 8? Now that 8 is represented by 1. How do you differentiate 9 and 2? And how do you differentiate 10 and 3?
Do I respond or another question?
Thank you, Dr. Wandera, for that presentation. It was a very nice presentation, although very abstract. Now, my question is, you have mentioned a new design, but also you have told us there are other designs which have been there. Now, in your validation, I don't know whether you have done it, maybe it has skipped me, but I didn't see you validating against the other existing design. Because what I have heard you mentioning is you have been comparing the performance of this design with the parent design that was actually used to create it. Why didn't you go maybe an extra mile to compare your design with other designs away from the parent design? And possibly maybe with some data that you can be able to show that the performance of your design is this as compared to the performance of the other designs using the same data.
So my question is very simple. First of all, it was very abstract for me. I did not understand most of it. So what are you doing? Can you explain it in simple terms?
I think I can take those three first, then I'll respond to the others if they are there. The first to my brother Kidego. Thank you for that question. There is something I mentioned here called modular algebra. Modular algebra deals with the remainder. And that is what is employed in this particular research. When you reach 7, the remaining, you use the remainder. So we employ the modular algebra. I would be saying 8, if I divide by 7, what is the remainder? It's 1, eh? So instead of writing 8, I go for the remainder. And I write 1. Same to 9. 9 divided by 7, because 7 was our limit in that case. So I would have maybe made it clear, if you understand modular algebra, that it is B over A and R, and I go for what? For R, where my A is the limit of V. I think that is clear. To Dr. Makondo, that's a very good question. I did QQ plots to compare how the efficiency of the some constructed designs perform vis-a-vis other designs like randomized complete block design, only that it is not in this slide. But I did QQ plots for that normality. In a simple language, what Wandera is saying here is that if you are given two designs, you can end up with a new design by simply taking the values of the lambda. And we did say the lambda is the number of pair of treatments appearing within that design. If you add them, you can get a new design. In the real life, where can we apply this? That is the question. Currently, even you call them this COVID-19, it is mitigating daily. So probably if you pick, I don't know we medical term how you'll use it, but if you pick a sample of the first wave, the second wave, then you can see how the third wave is reacting or changing. That aside, if you go to the field of agriculture where design and analysis of experiment is dominant, our data set was obtained from forestry, and it was done between 2018 and 2019, considering trees of the same species that are put together in terms of the numbers that we are calling lambda. Just a single tree, a pair of those trees, and then 3 of them put together. So the single one would be design 1 with lambda equals to 1. The one with the 2, replicated a number of times you'd want, is the design 2 with the lambda equals to 2, and then the number with the 3 replicated a number becomes now the sum constructed design. Diameters of these trees were measured at a given breast height, and that is what was used to arrive at the analysis of variance table where we were having our DF. So in a nutshell, you can employ this in terms of innovation, economic stimulus, and so on. Thank you. Any other? A clap for him, a clap for him. Let us restrict kindly request the next participants. This time I'll be raising after 5 minutes, after 8 minutes, and on the 10th minute itakuwa nikaa labda sijui itabidi nimesimama. Kwa maana tukingoja hivyo, we'll stay till the very last, we can stay here till evening. Oops. Sorry about that, because for those who are following us virtually, sorry you couldn't get it clearly, but I guess it was maybe for housekeeping purposes here. So I'd call the next presenter, Bwana Wigina. And I'd also like to know if Kibara is here, by a show of hand, if Kibara is here. Okay. After him, Bwana Rono, be ready. So since it's also multidisciplinary, and even those of us maybe in engineering, computer science, we could say it was quite abstract. You could try just simplify it like for a kid, and then we'll somehow get the gist. Thank you.
Good afternoon. I am Nyarambe Wigina, as I've been mentioned. I'm in medical science, and we did some work on blood, and basically I am in the area of studying your blood. If you remember, from time to time we tell you to give us some blood, and that blood can actually help to save lives. So I should mention here that this was part of my MSc work. This is the second publication from that work, and my supervisors were Dr. Kagia, Dr. Kahato, Dr. Mzee, Dr. Jeza, and Professor Gishangi. So I should also mention that. Before we could be able to, as human beings, as mankind, before we could be able to give blood from man to man, some of us actually tried to give animal blood to others. So some people could be given dog's blood, others could be given sheep blood, because maybe someone was mad. So because a mad person should be calmed down, and there's no animal as calm as a sheep. So we could take sheep blood and give it to this guy. So that's where we are coming from. So up until 1901, when now we said no, blood can only be given within the species. So human blood to human blood, dog's blood to dog's blood. So yeah, that's at the turn of the 19th century. So currently what we do for us to be able to give you blood is we do certain tests. These tests are for, I need to be as unabstract as possible. So these tests are for abnormalities that you have in your blood or that you have acquired. So diseases such as HIV, those are acquired. And we also have things like your hemoglobin level. That is what you have yourself. So these factors, ideally we assess them so that when now we give someone else your blood, they can be able to gain from it. So, okay. So when we take 1 unit from you, it relates to 1 gram per liter or per deciliter of hemoglobin for you. So meaning, ideally, when you have, let's say, we normally give below 5 grams per deciliter if you have below 5. So when you have below 5, let's say you have 3, if we give you 1 unit, then it's going to add your units to about 4. So normally, it is good to give about 2 units. So if, therefore, there are any abnormalities, for example, then they would affect you. Your disease condition maybe will worsen. Now, this project was to assess other than these other illnesses. So your red blood cells, so we were assessing our red blood cells. So our red blood cells may have certain conditions. So these conditions, if we do not assess them, then they may interfere with that level of giving you that therapy. So meaning, therefore, that we need to have blood cells that are okay, that do not have these conditions. Next. So because we need you to get well faster, to get out of the hospital faster, when we give you just enough blood, you can go. But if we give you blood that has abnormalities, then you may stay longer. So this is just to make sure that you actually we take good care of our patients. Okay, so the objectives were to look at the blood count, because during donation, we don't look at the blood count. Then we look at osmotic fragility, that is how well the red blood cell can survive. Then we also look at the hemoglobin lysis. This hemoglobin lysis gives us, it's a test that can tell us generally whether or not you have some illnesses, some trait illnesses such as thalassemia trait, sickle cell trait, things like that. So that test is a general test for that. And then you also have G6PD. This is an enzyme that also some of us have traits for that. And those make the red blood cell bigger, and that means the red blood cell is not going to be as effective as possible, because it's going to be broken down faster than the normal age of the red blood cell. Okay, so we did this study in conjunction with the Regional Blood Transfusion Center, and we used about 676 samples. And for the counts, for the procedures, we used those procedures, the Medonic for the red blood cell count, red cell lysis, we did osmotic fragility test, then we used the methemoglobin method to determine the G6PD, then osmotic fragility, we used the isopropanol test. So in our results here, we found that actually in donated blood, we have some abnormality. And we found that about 31.07% were actually not normal. Okay? So these are some of the tests that we did that we need to know. So the packed cell volume just gives us how well or how much, or the amount of hemoglobin, let's say, that you have. Same as the hemoglobin concentration. And then the total blood cell count, we need a certain amount of blood cells to be able to say that your cells are normal. So again, we had a few that were abnormal. Okay, next. Okay, if we did a descriptive statistics, and we found that basically the variation in the population, in the total red blood cell count was the one that was significant. Okay, so this is the G6PD, and we found that about 9.62% of the population that we had actually had a deficiency in glucose-6-phosphate dehydrogenase, and therefore they were prone to having the disease, G6PD disease. Next. Okay, so you also found that about 7% of the population also had fragile cells. Fragile cells are those that are not able to withstand increased salinity. So those were fragile. Decreased salinity. So those are fragile. Then next. And 3% were resistant. Now the resistant cells are cells that are smaller than normal, and therefore their hemoglobin level will be smaller. And actually this test can also tell us that you may have some illnesses such as sickle cell trait and other diseases such as iron deficiency anemia, which make our cells slightly smaller than normal. Okay, next. Basically, I've just discussed, so I think this is just a continuation of what we have just been looking at the results. So in conclusion, we are saying that there is G6PD in the population, and there is also the cells, our red blood cells in those donors. Most of the some of the donors, not most, some of the donors they have reduced or increased osmotic fragility, and therefore they may have some underlying illnesses. So we are calling then that for us to have a better grasp at this, we do a wider project, but we really need to re-evaluate our methods in hemoglobin estimation, and we also need to screen donors for certain illnesses such as the G6PD. Those are references, my acknowledgements to my alma mater, Kenya, KNBTS, TUM, JQuat. Thank you. Please donate blood. That's what we are saying.
A round of applause for him. So I'll pick at least 3 questions. 3 questions. Thank you very much, Bwana Wigina, for that good presentation. I was very curious to know. So my question is very brief. In the work that you did, the study that you did, were you able to do some case identification and tracing of, to identify if there is any prevalence from, like, so that you can actually give a conclusive statement which can actually be taken by even the World Health Organization? Like, for instance, you did it in the Coast General Hospital. Did you do like tracking so that you can actually say people who are from this have this, people from this have this? Did you go further than what you did to identify that, so that because I know some of these problems could be inherited from the genes? Thank you very much.
Ladies only? I think I'm through.
Thank you, Wiggs, for that presentation. That was a good one. I have 2 concerns. One, is it possible to trace those who dominated the bloods found to have anomalies? And then 2, maybe just to inquire how descriptive statistics could help you identify what is, I think, some significance. You did mention something about significance, but you are using descriptive statistics. Those are the concerns I'm having.
Okay, thank you. The first question is about whether we could get the people with these conditions. And this was a blinded study because there is a lot of stigma with those who donate blood. So for this study, we were not going to trace. We had an agreement with Kenyan BTS that we are not going to trace them. However, it will inform on policy so that we can actually have other tests done other than the normal tests that we do. We normally do blood grouping, hemoglobin estimation, probably physiology, your weight, your height, and we know that your weight will affect how much blood you can donate. So we are not going to trace that. So the other question is about the grades of blood. We don't have grades of blood. What we have, we do blood grouping. All of us have, our blood is same. The components, because all of us need that blood for our day-to-day activity. So the components of blood are there. However, the different levels of components of blood is our main concern here. And whether you have group A, group B, whichever group, there are so many, we have 37, actually 43 groups right now. So all those groups, same. So we don't have grades. And then the samples, we used donors. We took blood from the donors. So normally female are fewer. We had about 4% of females. So yeah, otherwise most of them were males. So yeah, then I've talked about tracing of the donors. I've said this was a blinded one. We don't want to continue stigmatizing them, yet we really need this blood. And so the only thing we want to do is to try and increase the test that we do so that we can be able to get our blood or get the best blood that we can get. And about the descriptive statistics, that was just a measure of variation. Remember, we need to know in the population if we have different, what is the difference in, for example, I have total red blood cells. These total red blood cells have a range. So if there are more people with few red blood cells, then we know that could be a problem for us. So that is why we did the descriptive statistics. I hope I've answered those questions. Yes?
I think you have not answered that question properly. I know there are grades of blood, or sorry, the groupings of bloods, A, B, C, whatever.
Yes.
But I was talking about the qualities, okay? Quality of blood. Is it possible to say that we can have different qualities of blood?
No, you know, we don't have. You see, even Hitler tried to do that, and that is why, yeah, Hitler tried to say those of blood group A are superior than those of blood group B. And he said that because of that, then the Aryan blood is superior, and he actually wanted to mate A with A. But it doesn't change the blood. The blood there's no grade. We can't grade blood. That's okay? Okay, thank you very much.
A round of applause. So I think the time management for that was way better. So the next presenter is Bona Apeli. So karibu sana. On the 5th minute, I'll raise a fist. On the 8th, I'll raise 2 fingers. Over to you. Could use the...
Yes, good afternoon to you all. My name is Moses Apeli. Oh, thank you. My topic is in hydrology, and my main concern was to model the impact of land use change to the suspended sediment of the River Yala. Most ecosystem changes are driven by land use changes. The land use changes originate from population increase. People move away from their homes to acquire forests. People move away from rural areas to urban areas. And in the process, we impact in several ways to the ecosystem. So my interest was in the River Yala, the river basin. So, on the introduction, we introduced about the scarcity of water. The scarcity of water that we need to use. Of course, there's a lot of water, but 97% of this water is actually salty. So we only have maybe 3%, and out of these 3, only 0.03 is what is in swamps and rivers. And that's the fresh water we can pump out and maybe utilize. So there's therefore that need to conserve. And then 42% of the population of the world lives in sub-basin areas. Naturally, people want where there are greens and where there's water. So if we don't conserve these sub-basins properly, then we are killing off 42% of the population of the world. Now Kofi Annan in 1985 set up a committee, a Millennium Ecosystem Assessment, that looked at these human-induced activities in sub-basins, and the report was pointing at a diminishing side of our population. Now, River Yala passes through about 4 sub-counties right now: Kakamega, Bondo, Siaya, and Nandi. There is a study by Jerry which he looked at this river specifically, but now he was sampling points. So he sampled all the rivers going to Lake Victoria at the entrance of the rivers, at the mouth of the rivers. Now, this formed the basis of my research, because now there were gaps. After taking those samples, he did go back to the rivers to find out what caused that erosion flow, and therefore he didn't do any analysis to advise on how to improve the situation. Yeah, we are trying to preserve the environment for the 30 million people who depend on this catchment, not just the Yala catchment. What happens in the Yala catchment affects the Lake Victoria catchment, and by extension, what happens in Burundi, Tanzania, Rwanda, Uganda, all the way. So Yala is the second largest river basin after Nzoia. Our business is to look at the long-term association of this land use change that has occurred to the suspended sediments of the river, of the Yala catchment. The main objective is what I've just said. Now, specific objectives, you will want to assess the temporal and spatial land use change of the river Yala. I will use the SWOT model, set it up, and calibrate it. Now, sediment moves in several ways. My interest is mainly suspended sediment, because this is what moves from point A to B. I'm not interested in the one that moves from one point to another, then it stops there. My research area is this basin. The Yala basin is a long stretch moving in those sub-counties up to the Lake Victoria. The altitude is this one. This altitude will eventually be used to delineate that area for further analysis. Some people have done research on this, many in Kenya, using the same model, Ngeno, Odira, Kivuva, and Mulei. So, to get the behavior of a catchment, you can't do it using any experiment. You just have to use a model. So there are several models that people have used, people have developed. For example, there's Mike Shea. This was from Denmark. This one, it can find out the parameters of a unlimited size of catchment. The problem with it is that it requires a lot of data. Now we have a problem in Africa. We don't necessarily invest in data a lot. So even the data we have cannot effectively run Mike Shea. We also have Akinfo, WIP, and SWOT. So my research will use SWOT model. SWOT is an American model. It is open source, and it's still managed. They still control it. They still own it. They have allowed users to use it for free. The research is divided into 3. In the first case, the model requires data, the digital elevation model, the stream flow, land use, soil, slope, weather, temperature, and rainfall. All this information can be gathered from our local, from our national bodies, except the digital elevation model, which is normally downloaded from the USGS. Just a minute. So from there, you put them into the watershed, you delineate, then form hydrological response units, and then run the model. So that you feed it in, then run the model, validate, then you get some output. I have primary and secondary data. Primary data, the elevation can be gotten from all that. Water quality and sediment, Arima. Soil map, there is a digital soil map that's on the net. The primary data will be the river discharge, which comes from our weather stations within the water catchment area, within the watershed, and the water quality. For that particular time, you have to select a period of time. For my case, I picked 1973, 86, and 2000. Looking at the landshed, the changes in the watershed between those periods of time. Those are the data needs. So that's how I'll set up the model. It's something I have done. I have reached a stage where I'm now analyzing the data. You look for the data, you look at the coefficient R squared, NSC, and maybe the glue. What did you get from the model? What is it on the ground? For spatial temporal data, the Landsat data, land use classes will be defined using a classified, supervised classification. That's just a procedure that is supposed to be used to get that objective, number 1. For objective number 2, this procedure that will be used up to where you are now evaluating the performance. Most of it is automated in the SWOT model. For number 3, after running the data, it divides this area into HRUs. So you can pick an HRU that has everything and use it to make some changes. Then run the model again to find out if you have improved the sediment discharge or not. Then you pick the best management practice. The model has all these parameters. There's a good thing about it. So you can introduce the issue of contouring, run it again, and see what you get at the end. Those are 3 expected results from my 3 objectives. So currently I'm here. That's it's not important because I'm paying it for myself. Some references there? I think that's all.
Any questions for Apel? Yes? Those with any other?
Can I go ahead? Okay, thank you. Thank you for your presentation. Mine was just a quick one. There's somewhere, I mean, a point you mentioned that there's a model, I don't know, from Denmark. But there's a model you said that is used, I don't know, from Denmark. But you mentioning that it can be used on limitless size or area, catchment area. I mean, no boundedness. I mean, to be clear, is there really a model that can be used on limitlessly? Thank you.
Okay, thank you, Apale. Thank you for presenting a good proposal. Probably I'm wondering, a model is already developed. Maybe I'll make it louder. I'm just wondering, a model is already developed. There is the mixture, there is the SWOT, and now you are employing the SWOT to give some characteristics. Could it be possible for you to model or give a new model so that you use your model to do the analysis? That is one. If that is two, then that is one. The next one, somebody would be asking, what is the main contribution or anything new that this particular proposal is intended to? Thank you.
Could there be any other question? So he'll answer the two before the next presenter.
Is there a catchment that is unlimited in size? The difference is Mike Shee can work on catchments like Amazon, big catchments. Not that not that there's a catchment that has no end. But from our case, mainly in Africa, our catchments are small. So when you pick a model that requires a big catchment, it means it requires a lot of data, and it means then you have to have that data. If you don't give it enough data, then your output will be wrong. Is it possible to create your own model? No. These models we are talking about are owned by countries. It is something hydrologists and engineers, a group of people have sat down and come up with. None of them was even developed in Africa. And there is no new one that we have even talked about as we are talking now. So we can only apply. What changes are the inputs and the type of model you're talking about? Each model has been designed to do a specific job. If you're talking about water management in reservoirs, then there's a model for that. If you're talking about management of erosion and other issues, there's a model. Each model has been designed for them for a specific reason. what is the new? What was the question? What is new? You need, after all this is done, you come up with the best management practices. You're saying, if this thing happens here, then this product, what we are having now, by the way, it runs for 30 years, from 1973 to 2008. So there is a trend which we need to arrest. So we are saying that if we did this, then we shall arrest this at this point. So at the end of it, you'll have to come up with a best management practice that you are advising the community. If you don't do this, then we are actually exporting our country to other countries.
Okay, thank you so much. A round of applause for him, tafadhali. A better one. Thank you. I'd like to know whether one Sami Fondo is here. Maybe just by a raise of, oh, it's Sami Fondo. And Bwana Kipkirui Rono, you're already there. Sawa sawa. So, Nikidani, I made some confusion. So he'll present first. Sawa sawa, I hadn't. So you can go ahead. Go ahead.
Good afternoon. Okay, I'm Kipkirui Rono. Recently graduated with PSc in Mathematics and Computer Science and specialized in pure mathematics. And I'm going to present you with a project titled The Infinitude of Twin Primes. Okay. So, before I continue, I need to define for us some of the terms so that we can understand what the topic is. So the first term here is, what is a prime? In simple time, a prime is a number which is divisible by 1 and itself. For example, 2, you have 3, 5, 7, 11, and 13. Now, what is twin prime or twin primes? These are primes which differ by 2. You have 2 primes which differ by 2. For example, you have a prime like 5 and 7. 5 is a prime and 7 is a prime. So you call the 2 twin primes. So the title is The Infinitude of Twin Primes. So the title is just telling us the twin primes are up to infinity. So this research is based on a conjecture called twin prime conjecture. And what is a conjecture in mathematics? A conjecture is a mathematical statement that is believed to be true, but it has not been proven. So this the infinitude of twin prime is based on a conjecture called twin prime conjecture. And the twin prime conjecture states that are there infinitely many primes p and p plus 2, or are there infinitely many twin primes? This conjecture has been there for a long time, since 1846. It was coined by a guy called Alphonse de Bollecan. So there are so many guys who have tried to prove this conjecture, but none has been able to give clear evidence that these twin primes are infinite. I don't know what the problem is. My pointer is not working. Okay. So a conjecture is a mathematical statement that is believed to be true but has not been proven. So I'm not going to go through the background history of this conjecture, but I'm going directly to the preliminaries. So in the first preliminary, you have what you call all twin primes. All these twin primes are in the form of 6K all twin primes except 3 and 5 are in the form of 6K minus 1, 6K plus 1, where K is a positive integer. So to prove this statement, proposition, let WC be any twin primes. For example, 11 and 13. So there is another middle value in between the 11 and 13, that is 12. Both of them are W and C are primes. So you have now the middle value. The middle value, let's say to be X. So you have now 3 consecutive integers. You have 3 consecutive integers, that is W, X, and C. In any 3 consecutive integers, you have 1 must be divisible by 3. But you are sure that your W and C are primes, so X is divisible by 3. Again, in any 2 consecutive integers, 1 must be divisible by 2. But you are sure that W and C are primes, so X is divisible by 2. So X has got 2 factors, that is 2 and 3. So X can be written in the form of 6K, where K is a positive integer. So with respect to our W and Z, with respect to our X, can be written as 6K plus 1, and then that one is 6K minus 1. This is what we need for our work. Then we go to twin prime categorization. We all know that any number that ends with 0, 2, 4, 6, and 8 is divisible by 2. That is true. So we are remaining with 1, 3, 5, 7, and 9. And we are sure that all primes are odd numbers. So any prime can end with 1, 3, 5, and 7, and 9. But again, what are we sure of? We are sure that any number that ends with 5 is divisible by 5. For example, 15. So 15 is divisible by 5. So we are removing 5. So we are remaining with, I'm sorry, I'm rushing with time. So we are remaining 1, 3, 7, and 9. So all primes, if you check, except 2 and 5 ends with 1, 3, 7, and 9. This one. 1, 3, 7, and 9. Now we are going now to twin primes. Twin primes has been categorized into 3 based on this. And we have 3 categories. The first category, those twin primes of the form 1, 3, those that ends with 1 and 3. For example, 11 and 13, 41, 43, 71, 73, 101, 103. And then the second category that ends with 7 and 9. For example, 17 and 19. And then the third category, that ends with 9 and 7. So we have a table here. Category 1, category 2, and category 3. So all twin primes get into this table. There's those that are in category 1, those in category 2, and the others in category 3. Now, I don't have to go through that. Lemma. Sorry. For each of the category, for each of the 3 categories of twin primes, there exists a positive integer n, such that the difference between any 2 twin prime pair is that n. For each of the 3 categories, the difference between any of the 2 is given by that n. Let's prove this lemma. From proposition, our first proposition, let 6k minus 1 and 6k plus 1 and another twin prime, which is 6z minus 1 and 6z plus 1 be any 2 pairs of twin primes from the same category. Okay. So from the same category. So what are we sure of? They end with the same digit. So if you find the difference, if you find the difference of 6c minus 1 and 6k minus 1, you are getting, you are like, if we use an example, table. If you use an example, for example, 41 and 43, if you find the difference, 41 minus 11, you are getting to be 30. So any other, you are getting to be, when you subtract, it is getting 0. At the end, it is 0. Okay, let's continue. Sorry. The other page. Okay. The other page. The slide is misbehaving. Okay, this one. Any 2 pairs of twin where k and c are positive integers, and then 6c minus 1, this one is I've explained. You will get that the difference when you find 6c minus 1 and you subtract 6k minus 1, you are getting something like this, t, where it is 6c minus 6k. And then when you factor out, you are getting something like this, t, which is equal to 6m. But what are you sure of this 6m? You are sure that it ends with 0. So that means it can be of 30, can be of 60, or 30. So in that form, you can factor this to the form of, therefore m is multiple of 5, which is the same as 6.5n, which is the same as 30n, where n is any positive integer, implying that the difference between 6k minus 1 and 6k plus 1 and the difference between this one and this one, which are 2 twin primes from the same category, is given by 30. Now our main theorem, which is twin prime conjecture, states that are there infinitely twin primes. Now we are going to do the main proof. Twin primes are infinitely many. Assume that our p and p plus 2 is the largest existing twin prime pair. Then from our lemma, there exists an integer n greater than 0, such that the difference between any 2 twin primes is given by 30. We are sure of that. Then there must exist n such that when you add our assumption, you assume this one to be the largest. So there must exist an n such that when you add, for example here, when you find P plus 2, when you add, that is added to P plus 2 gives another twin prime pair of the form P prime plus 2, where P plus 2 is another twin prime pair generated. Since the generated is greater than the original, what we had assumed, that's the contradicting the first statement that P plus 2 is the largest twin prime. Thus, our theorem twin prime are infinitely many is proven that there are infinitely many of twin primes. So in our conclusion, all twin primes have been categorized into 3 based on the last digit. And another thing, twin primes are infinitely many. Because of the interest of time, I will give just a simple application of twin primes or primes in general. In number theory, the most application is in cryptography or cybersecurity. So in cybersecurity, you have to have algorithm in order to encrypt your data. So without algorithm, you can't encrypt your data. So here we have a pattern where you can design your algorithm to encrypt your data. Thank you.
Round of applause for him. Could we have any questions? Any questions? Yes, that is one. Any other? I pick. I know who will be coming next. So yeah.
Thank you, Mr. Ronald, for the nice presentation, because your research is basically on the infinitude of many primes. And at the end of your research, I think you're finding out a proof. So I was just thinking, have you been able to apply your proof to infinitely many primes, aside from the ones that have already been generated on the internet, or where are you basically?
Is there any other question? We pick all of them before we answer.
Okay, Rono, that's good. We need to appreciate you. That's a good job. I just have a few maybe inquiries. When you say there is a lemma, is it Rono and Munyoki's lemma, or it is an existing one? Then you have grouped the primes into 3 categories. There could be something that informed the groups. Finally, maybe I'm just inquiring what informed the groupings. It's not a difficult question. Then if you say 6k minus 1, something 6k minus 1, the definition of k to me maybe did not come out clearly, probably. And then I was wondering if you use a given example of maybe 17 and 19 as 2 twin primes, would it still apply for the 6k minus 1 times that value? And then when I say the difference between every category 30n, where n is any positive integer, I think the word positive needs to be qualified better, because there is a difference with category 1, category 2, and so on. Probably you can go ahead and give the values of n in category 1, then category 3 and 2 in that direction. Thank you.
Okay. The first question, in my research, I was using, my machine was not compatible with this, so I had a program which I used to run twin primes. So I generated all the twin, like assemble of twin primes using a Python program, in order to study them. So after generating them, you can easily identify the pattern, or after generating, I categorize them, and then I now do the identification of the pattern. Then another question is the lemma. The first lemma was all twin primes, except 3 and 5, are of the form of 6k minus 1, 6k plus 1. That lemma existed, but the proof, I have done it on my own. Then another question was, what prompted you to do this research? Yes? Okay, for me, I did mathematics and computer science, and I specialize in pure mathematics. So during our project, we need to do a project. So I was looking for open problems in number theory. So, and then I found this twin prime conjecture. And that gave me a lot of, I wanted to know more about this problem, because it has been for a long time, since 1846. So I approached it as my supervisor used to tell us in our class, that you don't need to approach them to all of them, but just split them into groups so that you can identify some patterns or areas you can deal with them. That is what prompted me. I think I've answered.
A round of applause to Bonarono. Many thanks, many thanks. So we are remaining with 2 presentations, and then I'm told there are some people who are to come entertain us with some salsa. But wacha tumalizane nayo, and then we close the beat with some salsa, for those who are interested. Next is what's up, Bwana Sami Fondo. He's there ready with the presentation, and then will be followed closely shortly by Joseph Mbodhu.
Good afternoon. My name is Sami Fondo. I'm a master's student in the Department of Maths and Physics. My supervisors are Dr. Agri Adem and Dr. Kitty from Kwan University. My project title is Modeling of Petroleum Prices in Kenya using Arima and Var models. Okay, the growth of, okay, I'll start with the problem statement. The growth of Kenya's economy is partly driven by energy in form of electricity and also petroleum products. But find that the price of these products is quite unstable, and this makes the prediction of the prices in the energy sector unpredictable. Okay, this study is significant to the government, the private investors, and even the consumers of the petroleum products, since, like, for the government, once they are able to predict the future prices, then they can make good policies so that they can either maintain the prices, increase them, or decrease the prices. My main objective here was to develop suitable models for modeling the petroleum prices in Kenya so as to predict the prices in the near future. The specific objective was to construct suitable Arima and Var models. Okay, Arima is made up of 2 models, that is autoregressive and moving averages. I'll start with the Arima, with the autoregressive first. Autoregressive completely ignores independent variables, and it assumes that a particular variable makes use of its previous values, and even the errors has got information for purposes of future predicting of the values. So a pth order process is of the form yt given by alpha plus phi 1, yt minus 1 plus phi 2, yt plus 2 minus 2 up to phi p, yt minus p plus epsilon t, whereby yt is the dependent variable being forecasted at particular time t, and then alpha is the constant process, and then phi 1 up to phi p are the parameters to be estimated, and then yt1, yt minus 2 up to yt minus p are the values of the variable lags behind, and then epsilon t is the error term at time t. So for the moving averages now of order q is given by yt equals epsilon t plus theta 1, epsilon t minus 1 up to theta q, epsilon t minus q, whereby q is the number of lags in the moving order, in the moving average, and then theta 1 up to theta q are the parameters which have to be estimated. So my data was collected from 3 counties, that is Mombasa, Nairobi, and Kisumu. Now after plotting the set of data, I found that in those 3 counties, actually the trend is the same, as you can see from the diagram there. Therefore, I decided to pick on that one for Mombasa, because the trend is just the same in all the 3 counties. So in Arima, the first point to check here was to see if that data is stationary. But from here, we found that data is not stationary, as the data does not, the lag do not die quickly, as you can see from there. So to make the data stationary, it has to undergo what is called differencing. So as you can see from there, my H dot was super prices data has unit root versus the H1 super prices data has no unit root. So on the first one there, the test produces an ADF test, which is greater than the test critical values at all the 3 levels. But after cutting out the first difference now, it was minus 4.3004, which is lower than the 3 test critical values at 1%, 5%, and 10% respectively. Therefore, we say that the data became stationary after the first difference. Now, the Arima has got 3 letters, P, D, and Q, whereby D stands for the differencing. So since it became stationary after first differencing, our value of D here will be equal to 1. Okay, our next step was to find out the values of P and Q, because our D was already 1. So we got what is called the model identification. So in the process of carving my graphs, I had 3 candidate models. One of them was 100, 110, and then Arima 111, Arima 112, and Arima 113. So among those 4, I'm supposed to select the one which is most suitable. So and this is done by using the standard error, log likelihood, and the values of the AIC. So as you can see from the figure there, Arima 110 had the least value of the likelihood, and therefore it was picked as the best model among the 4. The next step was the parameter estimation, which I did through the maximum likelihood estimation, and these are the results. So from those estimation, I come up with those particular models for super oil price, diesel, and then the kerosene. Now from there, the next step is what is called diagnostic checking, whereby we check if the residues follow a normal distribution. This I did through the use of the normal QQ plot and the histogram. So from the 3 QQ plots there, I found that all the data points, most of the data points were lying on the normal line, except for a few of them which either deviate above or below the normal line for the 3 products. And then also in the histograms, the normal curves fitted very well on those 3 histograms, and that one also showed that it is a normal distribution. And here we have got the autocorrelation and the B-Legion test, which also confirms that the autocorrelations among the results do not exist, and therefore it is a good test. So after coming up with a model, I did a forecasting in the next 12 months, because my data was for 8 years from 2011 up to 2018. Then from there, I did a forecast for the next 12 months, that is January 2019 up to December 2019. So I come up with that. Now for the Var models, so the Var models here, it tries to look at different variables, unlike the Arima, which only specifies on a single model. For the Var here, we can have more than one variable. It is of the form yt equals m plus a 1, yt minus 1 plus a2, yt minus 2, up to a p yt minus p, and epsilon t, whereby yt is an n by 1 vector of the time series variables, m is a n by 1 vector of constants, and a is an n by n coefficient matrix. Also here, my dependent variables was the Petron prices, and the independent variables were the international oil prices, exchange rate, and the inflation rate. I was trying to see how they affect the prices in our country. So we see that all of them were non-stationary. So they became stationary after carrying out the first differencing. Okay, here now, I come up with the parameter estimation, and those were the results. And that became the model. Also here, I did a forecasting for the next 12 months, from January 2019 up to December 2019. Now, at the end now, I did a comparison of the 2 models to find out which one among them best predicts the prices in our country. So from there, the root mean square standard error for Arima 110 was 3.696349, and then for Var it was 2.701. The mean absolute error for Arima 110 was 2.562906, while for the Var was 0.936, and the mean absolute percentage error for the Arima 110 was 2.54307, and for the Var was 0.9332. Therefore, among the two models, Var had the least error of 0.9332, while the Arima 110 was 2.54307. Therefore, from my prediction, you can see that the Petron prices are not stable; they keep on fluctuating. As you have seen from the models, also the prices of this products is not stable. It keeps on fluctuating with time. In comparing the 2 models, the Var model was found to be better than the Arima model in modeling the Petron prices in Kenya. So we can recommend that further studies can be undertaken so we can compare other models like Gauge and exponential smoothing to find out which one of them, if they can model better than these 2 of mine. Okay, that was my reference.
Okay, thank you for the presentation. Any questions? Any questions from the audience? Naona daktari. Is your hand up? Okay. Any other question that we could be having? Is that hand going up? Oh, okay. Oh, and the second one. So, yeah, can start with.
Yeah, thank you, Fondo, for the presentation and really great improvement on your work. Maybe I want to get off into layman's language. So, does this help us? I think every morning I see the price is now 120 what? I've lost actually when I hear there is change in prices, I always like wait for the next. How does it help anyway? That's really my layman's question. In Kenyan situation, it looks to me it's like political. These guys just hike prices, I don't know. That's why I'm saying it's just a layman question.
Okay, thank you, Fondo, for the presentation. It was a first one. Modeling is a broad area, but usually when you model, you give your the regressors. I'm only concerned about the number you are using as the dependent. There are quite few. There are quite few, and that is why I think Dr. Munyoki is also wondering where would you put the political view or intention about it. Even the source of the oil or the petroleum you're talking about, where they come from and all those could have been part of your regressors. But as you respond to that, think of also responding what could have happened if in your, after differencing the first one, you don't find a convergence at that point. Will there be a change in your findings, or it will remain the same?
Thank you so much for the wonderful presentation. I would like to really understand the main factors that actually govern this project, because the oil prices in Kenya vary according to, for example, right now as we are talking, I really don't want to be political, but the factors we can see things like budget, the requirement from the government that this is the amount of money that needs to be raised. So the prices of oil will go up, and then this will affect actually how the prices are within the country. And then we have other external factors out there from the source of the oil itself. So I would like to know if these models that you use, if you actually had those factors in mind. And if you did, how did they drive you to come up with this, the conclusion that you have? Thank you.
So the question for Mr. is about the issue of the application to the common mwananchi. Okay. To the common mwananchi here, once you know the future price, yeah, you can be able to come up with a budget so that you can know how much you're going to spend on the kerosene within your house. Then you can know how much you can spend for the other goods that you want to buy. Because you have known that this month I'm going to spend this much on the kerosene in my house. Therefore, I've left this much for my other expenditure within my house. Okay. Yes?
Some answers to the other questions?
Yeah, I think one was maybe suggestion.
Oh, it was a suggestion.
Yeah. Okay, actually the factors which affect the prices of oil are quite many. Okay, like maybe you can have like the issue of the political scenario in the OPEC countries, whereby like the case of 1991 when Iraq was invaded by US, yeah? I think there was a energy crisis. Because when these countries are not producing the oil now, because of such political scenarios, then there'll be a crisis and hence the prices are going to rise. But for my case here, I was only considering the international price, the exchange rate, and also the inflation rate. But no, there are some others which I didn't consider actually. There are quite so many. Yeah.
Thank you so much. And a round of applause to Bonafondo. And for the last presentation of the day, Bwana Joseph Mbodhu.
Bonambodo.
I'm here to make a presentation on energy assessment of molasses-based ethanol production in Kenya. Let me first of all say this is part of some research work I've been doing on ethanol production in Kenya from sugarcane and also the sweet sorghum. So this is just part of the work. So just get that. Now, what's the background to my study? Biofuels are anticipated to be clean and affordable sources of energy. And therefore, again, access to clean and affordable energy, this is one of the sustainable goal number 7. Once you achieve this, you also achieve other sustainable goals, like sustainable goal number 1, to end poverty, sustainable goal number 2, to end hunger, sustainable number 8, and that is to promote economic growth. Also sustainable goal number 13, that is to combat climate change. Now, ethanol, when used as a fuel, it provides a substitute for fossil fuels. And again, ethanol production and use is again anticipated to contribute to energy security. And therefore, the information on the contribution of ethanol biofuel to energy security in a country from a particular feedstock is required so as to ensure sustainable production. What the statement to the problem? Energy input in biofuel production. This one is found to be sensitive to feedstock type, farming practices, conversion processes, allocation methods that are used for accounting for products, and also the local conditions. Now, these factors are the sources of uncertainties in estimating biofuel performance. This is in regard to energy. Thus, there is need to investigate the energy balance, energy balances in the determination of biofuel performance. And information on the contribution of biofuel to energy security in a country is required so as to determine whether its production is sustainable. What is the objective of this study? One is to evaluate energy balances in the production of ethanol from the sugarcane molasses in Kenya, and this is from a life cycle perspective. The significance of the study, one, is to provide data. This is for cleaner energy production. Also to provide information on energy efficiency on ethanol production. Now, the determination of energy balances from a life cycle perspective, this one will go along with contributing in making knowledge-based decisions, such as identifying parts of the life cycle of ethanol production where improvements can be achieved. Now, the quantification of energy balances during the process of ethanol production, this one again is desirable to help policymakers to take meaningful decisions. Now, I come now to the methodology. And here, what I'm considering here is looking at it. This is system boundaries. This shows the areas or parts in the life cycle of ethanol production, starting from the farm, sugarcane farming. Then we come to cane transportation, cane milling, biennial conversion from molasses, and also the waste separation pods. That's where the waste ends up. And you see, like for the sugar farming, you can see we also consider the farm inputs. We also consider the diesel, and also what comes out, that is the trash, the cane trash. Again, when you come to also cane transportation, you can see here the inputs here, the cane, sugar cane, and also the diesel. For the cane milling, of course, there is the addition of chemicals like lime and others which are added. So these are the inputs that you have in each of these steps of production of biennial from the sugar cane. Now, in my study, I used for determination of energy balances, I used Excel spreadsheets for data registration, and also the calculation of energy consumption, and also the energy balances. In my study, I determined the energy consumption in the production of farm inputs, that is for the fertilizers, the herbicides, pesticides, and also the energy consumption in industrial chemicals, which are used in the farm. And here I used energy coefficients from literature, mainly from a study from Katiwada and others in 2016, and another one studied by Macedo and others in 2008. I also determined the energy consumption due to use of diesel, that is in tillage, that is tilling the land, and also the use of diesel in transportation, both of the cane and so on. Here I used energy coefficients from the what we call IPCC of 1986. That is the International Panel of Climate Change. Then go back a bit. Then again, also there was this energy equivalent of agricultural labor because one of the inputs. And here I used the energy content cited by Nguyen in his study in 2008. Then again, there is energy consumption in the industrial phase, that is meaning biennial conversion, power cogeneration, and wastewater treatment. And again, here I got it from literature. The energy coefficients to determine all this. From Katiwada, we studied in 2016 with others, Macedo and others in 2008, Kumano and others in 2015, that was in India. For Katiwada and others, that was in Indonesia. Macedo, that was in Brazil. Kumano and others, that is in India. Then Mijewan, that is in Mauritius. Then Ashton in 2012 in Tanzania. Now here I've shown you how I got the allocation methodology that I used. I used what is called economic allocation. And this economic allocation is it's for partitioning the materials inputs, the energy inputs, the emissions that come out during the process. That is between the sugar and the molasses. Because these two, we get more sugar as one of the product and molasses as a byproduct. And now here in this study, I'm using molasses as the byproduct to produce biennial. In my study, for this economic allocation, I adopted the findings of these two gentlemen, Gopal and Kamen, in their study in 2008. And this is where the where they consider sugar and molasses prices in Brazil, India, and Indonesia. These are three countries where molasses, they produce the biennial from molasses. And what they found was that the sugar price was, in the three countries was 5.5 times higher than that of molasses. So that's what I adopted in my study. So I used that allocation ratio where I got the yield of sugar, that's the price of sugar divided by the yield of molasses, that is the price of molasses. Then I've just indicated the allocation that I did. And so the allocation ratio was in the ratio of 18.3 to 1. So that's the partitioning that I did between sugar and molasses. Now, then in my energy balances calculations, here the energy balances that I considered were three: the net energy value, the net renewable energy value, and the net energy ratio. And these ones are used to evaluate the energy balance of the biennial. For the net energy value, this is determined by the energy content of biennial minus the total energy inputs. For the net renewable energy, again, it is the energy content of biennial minus the fossil fuel input. Then the net energy ratio, this is actually the energy content of biennial divided by the fossil fuel input. What you should note, the total energy and the fossil energy inputs, these ones, what I determined them, but the energy content of biennial is this one has already been determined. It's 21.2 megajoules per liter of biennial. Now these are the results. This is the data that the data that I obtained from the field for the sugarcane farming, for the sugarcane milling, and also for the biennial conversion. This was in the biennial plant. So these are the results that I used for my determination of energy balances. Then this is now here indicating, this is how I used the Excel to determine the energy consumption and the energy balances. So as you can see from here, of the fossil fuels inputs are also renewable energy inputs. So from here, you can see the fossil energy input total was about 1.5. This was megajoules per liter of biennial, and the renewable energy input was about 15.87 megajoules per liter of biennial. And the total energy input now, when you add those two, you get 17.32. Then I determined now the net energy value, which came to about 3.88. The net renewable energy value, 19.75. Then the net energy ratio, which is 14.62. From these results, you can see the net energy value has a value, it's 3.8. This one is a positive value. And what this one indicates is that the energy required to produce biennial is less than the energy content of biennial. When you come to the determination of the net renewable energy value, is a very high positive value, indicating that the amount of fossil energy used is quite low. Again, the net energy ratio, 14.92, again a high positive value, again is indicating the same reason fossil energy was used to produce a renewable energy. Then I did the comparison of my energy consumption with other studies. This was a study done in Nepal by Katiwada and Severa in 2009. Another study in Indonesia by Katiwada, another in 2016. Then a study in Tanzania by Ashton in 2012. Then by Guen in Thailand. And from this, you can see the total energy consumption obtained in this study is less than that of Tanzania, Thailand, Indonesia, and Nepal in that order. From this, you can see the fossil energy used in this study, again, is less than that reported in Tanzania, Nepal, Indonesia, and Thailand in that order. Now, in Tanzania and Nepal, the high fossil energy use, this one is attributed to the use of diesel for irrigation purposes. These two countries. In Thailand and Indonesia, the high fossil energy use, this one is attributed to the use of coal in the production of energy. And again, what I noted was that the source of energy of these countries, in all these countries, is primarily from renewables, contributing 87% to about 87 to 96% of the total energy consumption, except in Thailand. Then I did the comparison of energy balances with other studies, again with the same countries. And again, what you observe, the net energy value obtained are positive, except that one of Nepal, which is negative. Then when the net energy ratio, again obtained in this study, again indicate that less amount of fossil energy is used to produce 1 liter of biennial in Kenya than in Tanzania, Nepal, Thailand, and Indonesia in that order. And again, I've indicated the reasons why the fossil energy use is high in Tanzania and Nepal, and again in Thailand and Indonesia. I also did sensitivity analysis where I determined the variation of the net energy ratio with the changes with the biethanol yield and the price of molasses. And this is what I obtained. What you can see from my graph here, when you increasing the biethanol yield results in an increase in energy ratio. And again, here, an increase in biethanol yield, this one leads to a decrease of resources per the fractional unit. Here, the fractional unit is 1 liter of biethanol, hence increasing the net energy ratio. Again, when you increase the price of molasses, this results in decrease of net energy ratio. An increase of the price of molasses will lead to a higher allocation. When you increase the price of molasses, this one leads to a higher allocation of resources to molasses. And this will have a consequence of reducing the net energy ratio. So in many conclusion here, the calculated values of net energy value, net energy ratio, this was 19.75 and 14.62. This is megajoules per liter by the node respectively. Then again, what you observe is high positive values of both net energy ratio value and the net energy ratio. Again, what it indicates here, less non-renewable input resulting in less. Once you have less non-renewable input, this one results in less greenhouse emissions. Again, my recommendation was you produce, my study recommended that the use of the production of biogas from the wastewaters. Because biogas is a renewable energy source, hence its use in biethanol production will reduce the use of fossil energy, hence improve the net energy value and the net energy ratio. Thank you.
Thank you, thank you. A round of applause to him. Any questions to the presenter? Yes, there is a question by Dr. Pale. Any other question?
Yeah, thank you, Bwana Joseph, for your presentation. Why comparison between those is it 4 countries, Tanzania, Nepal, Thailand, and Indonesia? I'm saying why comparison only between Kenya, Tanzania, Nepal, Thailand, and Indonesia, not the other part of the world? Thank you.
Okay. Let me say this. I have in my this presentation, I have just considered some of the countries. I have also resourced for you Ethiopia, Mexico. Yeah? But for this study, I just took a view of them. So that my presentation doesn't take a lot of time. That's what I thought probably. Probably I don't know whether I was right. But in my work, research work, I have considered other countries, like I have said. But what I found, biethanol production in our country is, when it comes to this, the net energy value and the net energy ratio, it is well placed because the values, the net energy values and the net energy ratios are very high. So indicating that we have avoided too much of the fossil fuels.
There be any other? I see there is a hand up. Could be
Thank you for the presentation. This is a very vital part of the economy in Kenya right now. And my concern is just, I would like to ask, because I have seen from the figure, I think you were talking about allocation, the methodology about allocation.
Yeah.
It is a lot of, like 1 ton of sugar produces, 1 ton of sugar cane produces 100 kilogram of sugar. So I would just like to ask, are there things, or are there measures that maybe are supposed to be taken so that there's increase in molasses? Because if this is if there has to be a transition, that means we need to have quite a huge amount of molasses in order to produce energy and to become actually as a substitute, because we talk about being a substitute of fossil fuels. So is there anything that needs to be done in order to improve the quantity of molasses, bearing in mind that the amount of sugar being produced here in Kenya is a very small amount that cannot cater for that?
You're talking about allocation, allocation methodology, or yes? You see, in the production of sugar, mainly the aim was, in most of these sugar factories, is to produce sugar. But then, in the production of sugar, they produce molasses, and molasses was a byproduct. And most of it, initially, it was going to waste or sold to farmers. But now, the most like Mumia Sugar Company, what they did, they came up with a bioethanol plant where they were to produce bioethanol from the molasses, which used to be a byproduct. So again, what the idea here is, during my study, what I found, they produce about. If I can go back to my where results, If you go to my results, where it starts, results and discussion, just to show him. Just go ahead. Now here we are. If you look here now, you can see the molasses. You produce 4 kg for every liter of bioethanol that you produce. 4 kg of molasses is used. So here, molasses is a byproduct. So we want to make use of that byproduct to produce something, again, which the company can make money. Yeah. So here is not we increase the amount of. The aim is to produce sugar, but now here we have a product which has to be, the company uses of it to produce now bioethanol. I hope we are okay now.
Okay, a round of applause to Bonambod. A huge thank you to all of us, and especially the presenters, for the wonderful presentations you've made. It has been a long day, and to all of us who are still here, you're the last people standing, and on behalf of the organizing committee, let me thank you very much. We don't take it for granted. So many thanks. Could I ask maybe a volunteer to close for us with a word of prayer? Tomorrow's session, tomorrow will be a really packed day, because it's when the official opening by the chief guest will be done by 7. So you can get enough rest for a great day tomorrow. And the icing on the cake, kutakuwa na opening, or let's say it's the official opening of some center, official launch of a journal, the TUM journal, the papers that were presented in the very first, there is a journal that is there, so there'll be official opening. And the icing on the cake, at least there'll be some cocktail tomorrow. So thank you so much. Any volunteer to pray for us? By standing up, are you volunteering? Thank you.
Good evening, everyone. All protocols observed. Good evening. Let us bow our heads for a word of prayer. Father, in the name of Jesus, we come before you this wonderful evening, glorifying your name, Lord, saying that, Lord, you are Yahweh. You are the Alpha and the Omega, the beginning and the end. Lord God, you have led us through since, oh God, when we began this conference today, God, in the morning till this evening, Lord. You have come to an end of day one. How we thank you, Jesus. How we glorify your name, Lord. How we say that you are worthy of all the praise and adoration. Now it's our prayer, mighty King of all glory, God, that you lead us through, even in day 2 and day 3, mighty King of all glory, God. And let every program run as per your will, Lord Jesus. And even as we depart, Almighty King of all glory, God, I will ask you that you grant us journey mercies to wherever we are going, Jesus. I will ask you, the mighty King of all glory, God, you protect us and lead us through in everything for the glory of your name. For this you do pray, believing and trusting, God, that, oh Lord, Father, you have heard you and you have answered according to your will. And all that we have not prayed, Holy Spirit, we ask you to pray for us before our Father and Daddy in heaven, Lord, we ask you to answer for us. And all that we have prayed wrongly, Lord, we ask you to forgive us. For it is in the name of the Father, the Son, and the Holy Spirit we pray. Amen.
Thank you.